It's Alex with Code Along with Alex. Let's get back into it. This is part 2 of Rust by Example Flow of Control. So let's get started. I'm going to create a project today with Cargo to house our first example. We're going to do destructuring tuples, and we're going to destructure using a match keyword. So let's do cargo new des tuples. It's a little easier to type. Cd des tuples. And then let's open the main.rs. Okay. I'm going to leave that println statement later because we'll just replace it with some other text. To start, let's create a tuple variable called triple. And we'll just put in some values to -5 and about 41. Not bad. Okay. And so now, actually, let's use this print keyword to print out the values. So we'll just say tell me about, and this is our debugging format. And we're going to tell me about triple, and it'll just print out triple for us. And now we're going to start with our match keyword, and that's how we're going to destructure this tuple. And so to start, let's, I'm just going to do this kind of boilerplate that I can copy paste a few times just to save myself a little time. Println, okay, and then a comma. Okay, and then a comma on the outside. And then I'm going to copy this just to save a little time. 1, 2, 3, 4, and then the last one. Type out. Great. So for this, we'll start with 0, Y, and Z. And then we want to print out. First is 0. Y is whatever Y is. In our case, it's going to be -5. And Z is, again, whatever Z is. In our case, it's going to be 41. And then we pass Y and Z. And then we move on to our next case in the match branch, or next branch, I guess. Okay, for this one, we'll do 1. This one will be just kind of whatever. So kind of just ignoring it. So we'll say first is 1, and the rest doesn't matter. And that's it. Okay. This one we'll do kind of the opposite. We'll do ... and then here we'll put a 2. So last is 2, and the rest doesn't matter. And then we can do, actually we don't need to pass anything there either. Great. Okay, and here we'll do 2, or 2 values. So we'll do 3, and then we'll just ignore the middle value, not all values after the first or all values before the last. And then we'll pass a 4 for the third value. And so we'll do first is 3, last is 4, and the rest doesn't matter. Cool. And then we actually need one more case for all others. And so this is just kind of ignoring everything. Yeah, I got a space in there. It's hard to tell sometimes. Okay, print ln. It doesn't matter. what they are. Okay, and then we can do a trailing comma there. Doesn't hurt. Let's save that. Let's run our code using cargo run. Tell me about 2, -541. It doesn't matter what they are. And so none of the cases were matched, or the branches. Let's tweak a value. Let's replace the first value with a 0, just to make sure things are working as expected. First is 0, y is -5, z is 41. Cool, I'm satisfied. And with that, we can move on to the next section of destructuring for today, which is arrays and slices. So I'm gonna change back out of this file, or at this directory, create a new cargo project for cargo des arrays slices. Let's change into that directory and get going. Open up the folder tree very briefly. Get main.rs in our view on the editor. And let's get going. Delete our boilerplate hello world. This time we're going to find another variable, not a tuple, but an array. So let's put in some values. 1, -2, 6. Great. And then right into our match arm. And this is just to say that, like tuples, arrays and slices can be destructured using match, which is quite nifty. So let's do 0. I'm not going to do the copy paste this time. Didn't really save that much time. I mean, it did, but can't hurt to type. You can, I guess you can get carpal tunnel, but we won't worry about that today. Okay, array index 0 equals 0. Array index position 1 equals whatever it is. Array index position 2 equals, again, whatever it is. And then passing second and third to interpolate whatever they are. Cool. Let's throw a comma there. Next match arm. This time we got 1, kind of ignoring the second value. And then passing third for the third value. And if that is the successful match arm case, then we will print out array position 0 equals 1. Array position 2 equals whatever it is. And array position 1 was ignored. Ouch. It hurts. And then we'll just pass third. Oh, I need to do that in here. Third, yeah, because that'll be interpolated for the second array integer, or array index 2. Okay, on to the next case. Oof. Guess I could have done the copy paste, but it's fine. Practice makes perfect. -1. Second, ... If that matches the input, then we will return this print statement. Array at integer, or at index 0 equals 1, equals -1, excuse me. Array at index position 1 equals whatever it is. And all other ones were ignored. And then we'll pass second. So that will be interpolated here. Great. Throw a comma onto the second to last arm in our match statement. Here we'll pass a 3, a second, and then a little bit of fanciness, tail at dot dot. And so this is going to store them in another array slice. So let's see what happens. Print len array at index 0 equals 3. Array at index 1 equals whatever it is. And the other elements were whatever they are. Okay. And then we'll pass second and tail. One last one. Okay. And then finally, we'll do first, middle, at, last. Println array at index 0 equals whatever it is. Middle equals whatever it is in debug format. Array 2 equals whatever it is. And then we pass first, middle, last, leading or trailing comma. Press Control or Command Save, depending on your operating system, and then slam cargo run. See the results. So array 0 equals 1, array 2 equals 6, and array 1, or array index 0, array index 2, and then array index 1 was ignored. So we actually matched the second case. Let's now see what the last two kind of cases match. I'm very curious. So I'm going to replace this with a 3. Saved it. Now I'm doing cargo run again. And you can see array index 0 is 3, array index 1 is -2, and the other elements were 3. And you can see where I had a typo here, which is fine. And you can see that for the tail value, nothing crazy was happening. Interesting. So what happens if no values are matched? Let me change this to just like a 7. So array 0 in array index 0 is 7, middle is -2, array index 2 is 6. Okay, nothing crazy. We're just binding values and little trickery, nothing too wild. Okay, that's it for destructuring arrays and slices. Next, we're on to destructuring enums, and it's very similar. So let's have some fun. Cargo new des enum cd des enum. Let's close this main rs. Toggle into des enum. Open the main.rs. Close this. Close that. Start typing. So to start, we're going to actually create an enum for ourselves. We're going to pass the allow dead code flag so the compiler doesn't yell at us. It's been a while, but it's good. It's just required so we silence warnings because only one of the variants from the enum is used. But yeah, let's go. We're creating an enum called color, and there's going to be 3 that are specified solely by their name, and then the rest are going to be tied to color models. So we got red, blue, green, Then we got RGB, U32, 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 HSV, hue saturation V. I don't remember what that is. U32, 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 HSL. Yeah, I'm not gonna even. I don't know. Is this like cyan, magenta, yellow? I don't know. CMYK. No clue. Getting a lot of practice typing U32. Okay, we got our enum ready. Let's get into typing the actual main function body. So to start, let's declare color equals color, and we're just going to pick the RGB variant of the color enum, and we're just going to pass some values, some U32 values, to define our RGB color. Very cool. Now, let's println what color is it? And then, you didn't guess already, got some match. Got some match. So we got color. We can type it out. You know, it's just practice. It's fine. Don't hate me. It's not the most thrilling thing to watch, but it could be worse. So if it's blue, I'm working on background music. Meeting up with my good buddy Andy tomorrow, and we're gonna get some nice lo-fi elevator tune vibes for Code Along with Alex to fill the void of me typing and accidentally making ASMR content. It's an unexplored niche. Live coding ASMR. We're at the bleeding edge here at the graph on many fronts. Okay. RGB. I'm just impressed with my, I'm improving my ability to live type as I mess up. I was boasting, and then instantly the universe was like, nah, Alex, calm down. You're not that good. I was just trying to hype myself up. Like, man, you're getting a lot better at like typing and talking. Like the multitasking brain. Sort of. It's a process. I don't know. I'd encourage anyone interested in a good challenge. Try to live code and talk. Like narrate what you're doing. It's actually kind of challenging. Was not expecting it, but it's been pretty fun as I make all these typos. But typos are part of the process, even if you're not narrating what you're doing. So it's honestly just good practice and helps improve your ability to explain what the heck you're doing to others. You'll never be perfect, but you can always get better. Okay, enough rambling. I'm just doing kind of print statements that apply to the specific variant of the enum. So for the RGB enum, just interpolating into the curly brackets the values according to the data model. So for the HSV variant, hue saturation value. Okay, so value is just value, V is just value. Interesting. I would have not guessed that. The more you learn, or the more you know. Okay, color, HSL, HSL, PSL, pumpkin spice latte. It is November. I have not had a pumpkin spice latte in a while. Cyan. Oh no. Hue. Saturation. Oh, some competition. Value. Lightness. Okay. And then this is just HSL. Almost there. Second to last one. CMY. This is where's the cyan. I got excited about cyan. Ooh. Print LN. Cyan. I like cyan. It's a nice color. Magenta. Yellow. I was right about yellow. Okay, cool. I thought I was yellow. Okay. CMY. Awkward spacing. Okay. Color. CMYK. What is K? Black. Oh. Sorry if I ruined it. I forgot that K is used as black in like other libraries too. Like plotting libraries, so that makes sense. I guess it's like an old school way to denote black. Println. Cyan. Whatever it is. Magenta. Whatever it is. Yellow. Whatever it is. Key. AKA black. Whatever it is. C. M. Y. K. Trailing comma. Don't need another arm because all variants have been examined. Sweet. Okay. Control save. Just do cargo run. Ooh, and we got an error. Okay. This pattern has 4 fields, but the corresponding tuple variant has 3 fields. Okay. Oh, I needed to add an extra U32. Okay, that makes total sense. Let's go back and run it again. And we're good. So what color is it? Red 122, green 17, blue 40. And that's what we declared. Okay. What if we say let color equals color red? Color's red. Okay. I'm satisfied. That was enums. Now, oh, getting there. Okay, second to last destructuring section. Pointers and refs. Okay. Let's go. Let's create a new cargo project. Cargo new. Des pointers ref. CD into that folder. Open main.rs. Let's get going. So for pointers, a distinction needs to be made between destructuring and dereferencing, as they are different concepts which are used differently from languages like C++ and C. So dereferencing uses the asterisk symbol. So I'm just going to delete this. So dereferencing uses this, whereas destructuring uses asterisk. Correct. The asterisk. Or not the that's the ampersand. Ref and ref mute. Hitting all the shortcuts that I don't need. Okay, let's make a reference. Let reference equals reference to 4. Okay, and so then let's do a match. Match. If it matches a reference to a value, let's print out that value in a statement got a value via destructuring, and then we'll use our debug format and pass the value. And that's our only case in this match arm. Cool. Next, let's create another match case. And so to avoid the ampersand, we can dereference before matching. So we can do match asterisk reference val, and then just println got a value via dereferencing. That looks like it's spelled weird. Okay, and then val. This should actually be val. Okay, and that is the only branch in that match as well. Okay, cool. But what if you don't start with a reference? So reference was not an ampersand because the right side was already a reference. This is not a reference because the right side is not one. So let's actually try one that's not a reference. Let not a reference equals 3. Let reference is a reference equals 3. Okay, and so Rust provides the ref keyword for exactly this purpose. It modifies the assignment so that a reference is created for the element. This reference is assigned. So if you need a reference, use the ref keyword. So accordingly, by defining two values without references, references can be retrieved via ref and ref mute. So let value equals 5. Let mute value equals 6. So let's do some more matching. Match. And so we're going to use the ref keyword to create a reference. Match value. The P is right next to that curly bracket, so that's why I'm getting that one with my ring finger. Ref to R. I've noticed that Rust really likes that curly bracket with my right ring finger that is not strong whatsoever. So I'm building up those finger muscles, or carpal tunnel, whichever. Doesn't hurt yet, so that's good. I'll stop if it does. Retire. Okay. So we're just printing out got a reference to a value, and we're just gonna print out the reference to that value R. Cool, and we just got one arm in that match branch. Finally, we're going to use ref mute similarly. So match mute val u ref mute m. So we got a reference, got to dereference it before we can add anything to it. So we're going to dereference m and then add 10. Print we added 10 mute value m semicolon, and then just add a nice comma right there, and then delete some of these extra blank lines for tidiness. Press Control Space and we're good to go. Let's do cargo run. Got some errors. It's always fun. A little scary, but fun. Okay, so what do we have here? Expected one of 8 possible tokens. Interesting. Match. Oh, I forgot to put reference here. There we go. Actually, let's clear this to make it a little easier to see the error messages. Oh, so that's much shorter. Oh, and I'm just missing a colon. Wonderful. So this is line 30. Yep. Clear this out. Run it again. Wonderful. Got a value via destructuring 4. Got a value via dereferencing 4. Got a reference to a value 5. We added 10. Mute value 16. Okay. Nice. Let's continue on our whirlwind tour of destructuring. And now we move on to our final destructuring section, structs. So let's change out of this directory, close the file, cargo new, des, structs, cd des, structs. Close that. And similarly, a struct can be destructured as shown. Say that 10 times fast. Destructuring a struct, destructuring a struct. Or a struct can be destructured. Struct foo x. A tuple of type U32, U32. And then y, U32. Let foo equals foo where x equals 1 and 2, and then y equals 3, semicolon, and then you know it, let's do a match. Match foo x 1 b, and then just y, whatever it is. Print ln first of x is 1, b equals whatever it is, y equals whatever it is. Pass b and y, and then a trailing comma onto the next branch. Foo, where y is 2, and then x is I. Print ln y is 2, I is debug format vibes, and then I. And then for final branch, we got y dot dot, and then we'll just print out y is whatever it is, and we don't care about x. And then we'll pass y, trailing comma, Control S, Command S, depending on your operating system, and then cargo run. First of x is 1, b is 2, y is 3. What happens if we change this to a 9? Y equals 3, and we don't care about x. Sweet. And with that, we finished destructuring. Next, we can move on to guards, which is another exciting topic. I'm not sure if I'm being sarcastic or not, but let's learn about guards. Cargo new. Guards. CD guards. Let's open main.rs and guards. And so a match guard can be added to filter the arm. So let's create an enum called temperature. So we got Celsius, which takes an integer 32, but it can be with a negative symbol. Then we got Fahrenheit, integer 32 as well. That does it for our enum. So let's go back to our main function. Let's do let temperature equals temperature Celsius 35 match temperature Celsius T if T is greater than 30. Ooh, I like that. Print ln, whatever it is, C is above 30 Celsius, snazzy T. Okay, next branch, Celsius again, T, and this one, no guard. So we'll just print out whatever it is, C is below 30 Celsius. T. Next, we'll move on to Fahrenheit. T. If T is greater than 86. Ooh, nice and warm. I like it. F is above 86 Fahrenheit. T, and then our last branch, no guard. It is below 86 Fahrenheit. T. Let's run that code. Cargo run. 35C is above 30 Celsius. Let's try this again. Let's do let temperature Fahrenheit about 88. 88 is above 86. Okay. But note that the compiler won't take guard conditions into account when checking if all patterns are covered by the match expression. So let's, I'm going to comment out this code just so we can do a quick one of a different example. So I'll do fn main, let number of type unsigned integer 8 equals 4. Match number I if I equals 0. Print 0. If I is, or I, if I is greater than 0, print ln greater than 0. And then all other cases. But if you think about it, this does, yeah, you can't reach this branch arm because with unsigned integers, there's never any values below 0. So they're always either 0 or greater than 0. I don't even think unreachable is a macro. You know what I mean? Let's try it. I think that's like a joke in the docs, but I guess not. Interesting. Okay. I was expecting some sort of error message, but I guess not. So I guess it's the compiler won't let us know. Interesting. Okay. And then for today's next session, or next, yeah. Ooh. Clicked out of where I was. But yeah, for today's final session, or final example, we're going to do binding. So indirectly accessing a variable makes it impossible to branch and use that variable without rebinding. Match provides the @ sigil for binding values to names. So let's get going. Let's do cargo new binding. Let's cd binding. Open the main at rs. Let's create a function called age that returns a type u32, and it just returns the value 15. Okay, so then we got our main function, and so let's just do tell me what type of person you are. Match age 0, or if age is 0, print ln I haven't celebrated my first birthday yet. Could match 1 through 12 directly, but then what age would the child be? So instead, we're going to bind to n for the sequence of 1 through 12. And then now the age can be reported. So that's pretty dope. So n 1 12 print ln I'm a child of age whatever it is, n at 13 through 19, print ln I'm a teen of age whatever I am. And then nothing is bound, so we'll just return the result. It's a different value. N print ln I'm an old person of age whatever age I am. Cool. Save cargo run. I'm a teen of age 15. Let's change that to, bro, I'm 31 as heck. I guess I'm an old person. Struggle, dude. The struggle. Cheers. To wisdom. Okay. Actually, I preemptively left binding. So we're actually going to do one more example in this file before we call it a day. So we can also use binding to destructure enum variants such as option. I think this is, I guess before I dive into that, I think this is pretty sick. This kind of binding and how you can filter the sequence like this. Like that's kind of cool. Yeah. The sigil. It's fancy. It sounds like a video game. Okay, so some name and some number. And it returns an option type. U32. And sum 42. And so then the main match some number. Yeah. So sum, got that sigil life again. Sum n 42. Println the answer. I'm gonna need the debug formatting, cool. And then match any other number, sum n. Not interesting. And then we're going to match anything else. Cool. Let's do cargo run. The answer is 42. Okay. What if we do 43? Not interesting. And then what if we do none? See, just nothing's printed out. Cool. I like it. On that note, we're going to call it today. We have 2 more sections in flow of control, so this is going to be our first 3-parter, but it's a lot of content. So I'll be back soon with part 3 of flow of control, but thank you for hanging in there and coding along with me. I'm Alex. This has been Code Along with Alex, and I really appreciate your company and look forward to the next session with you. Have a great day, and see you next time.